Hi, the section 4.4, the prediction and effective doses. So we have two concepts. So one is the prediction, especially that we think about the confidence interval. And another topic is effective doses. So this is just a kind of the threshold value. Okay, so first the confidence interval for probability. So it's a kind of prediction. So confidence interval for probability P, that is the G of eta. So G is the link function such as logit. Maybe I would say the inverse logit, I have to say, and this is the inverse link function. Actually, the G inverse is the link function. So this is the usually, okay, so if we think about the confidence interval for P, so the interval is usually wider as the expected probability is closer to 0.5. So that means that if the center of the probability, expected probability is 0.5, then confidence interval may be wide, such as 0.3 to 0.7. But if the estimated probability is very high, for example, 99%, 0.99, then confidence interval may be the 0.85 to 0.999. So it's shorter in terms of the probability. So yeah, and why this happens? Because this happens due to the shape of the link function. So think about what's happening between the relationship between the eta and the p. So eta ranges from negative infinity to positive infinity, and p ranges from 0 to 1. And basically, we transform the confidence interval for eta to confidence interval for p, because the p is equal to g eta and eta is equal to x beta. So basically, okay, so beta has some variability because it's estimated by beta hat. So variability of beta hat, the transforms into the variability of eta hat. Then after that, we estimate p. So if eta has the same width for two estimation, so one is, okay, so estimated eta is here and the band is here, and the other prediction for another observation, the predicted eta is here, then interval is here. So even if the range is the same, so the size of the intervals are the same, if we think about the projection onto the space of P, then confidence interval is somewhat wide here. But if we think about here to here, confidence interval is pretty narrow. You can see here to maybe here. So confidence interval is pretty narrow. So confidence interval for P is much narrower than when P approaches to 1 or 0. Yeah. And also we have the a kind of the another effect. And remember that the data points with their predictor values far away from the center have larger confidence intervals. Okay, so actually the larger estimated eta or smaller estimated error eta. So that is caused by observations far away from the center. And remember that if we have the x and y, then confidence interval usually looks like this, because confidence interval is basically the region where the regression line is included. So confidence interval is the area that regression line is included. So it's hyperbola. So it has wider confidence interval for larger x or smaller x, wider, and narrower at the center. Okay, so this has kind of the opposite effect. So if the eta is around the center, then actually this interval is slightly wider. But that effect isn't that large. You can imagine that unless the eta is very extreme, then size of the confidence interval for eta is very similar. And the effect for the shape of the logit function is much larger. So actually, if the probability is closer to 1 or 0, then the range is usually smaller. And the next page, next 2 pages, they explain that situation. So we calculate at first the confidence interval for eta. Okay, so that we use E because the confidence interval for eta. And this is the center, and this is standard error. So this is for eta. So this is estimated eta. I mean estimated eta. And this is standard error. So standard error of eta. So we have to say the eta hat plus minus 1.96 times standard error of eta hat to get 95% confidence interval. And that is something I didn't display it. Then I used the inverse logit function to get the estimated probability. So this is the confidence interval for P given concentration is equal to 2. Concentration is equal to 2 is at the center. So actually, this has 50% probability, just by chance. And the range is from 0.4 to 0.6. So confidence interval has the length of 0.2. Next page, we do the same thing, but at concentration is equal to 4. So kind of x is equal to 4. And the fitted probability is here. So this is eta hat. And in the previous page, eta hat is almost 0. But here, 2.32. So it's on the right end, almost near the right end. And the standard error of that. So the eta hat, standard error. And actually, this value is much larger than the previous one. So 0.418. And the last time that was 0.207. So this is the effect of the confidence interval. So you can see this effect. So center, it's smaller, and at the end, it's wider. So this effect appears, and actually twice as wide. 0.207 becomes 0.418. But when we think about the inverse logit function of eta hat plus minus standard error of eta hat, so here the range is 0.818 to 0.959. So the center is, I didn't really write down the center, but the center is just the center. And actually it's little narrower. So you can see that this range is equal to 0.141. So last time that was 0.2. So it's narrower. So as probability, the approaches to 0 or 1, the range gets narrower usually. Yep, and how to calculate the confidence interval from scratch. So here is the answer. So remember that the variance of beta hat is given by x transpose w times x. So w is basically the p times 1 minus p. And that we have some adjustment for the number of observations. And yes, then the variance of eta hat. So next one is variance of eta hat, and finally variance of p hat. But the variance of eta hat is calculated by variance of x naught times beta hat. So variance of something times random variable is the this shape. Yeah, so maybe to be exact, so this should be the prime of x naught. X naught is just a predictor for the specific observation. So you can calculate by using this. So x is the model matrix, and the w is given by the diagonal matrix of these probabilities, and the piece observations, ice observations. So yeah, so you can calculate in this way. There are some examples in the textbook to use this formula to calculate confidence intervals. Yeah, so the next one is the effective doses. So in a simple, that means the single predictor logistic regression, the k% effective dose or lethal dose is the x value which satisfies this equality. So just we want to find the threshold for x, which gives k% probability for success or death. Yeah, and so that x. So just to solve this equation for x. So you transform this by logit function. Then logit of k over 100 is equal to this one. Then we solve this for x. So x is equal to the logit of this percentage minus beta naught hat over beta 1 hat. So this is pretty simple. So we will not have an example, but this gives the threshold value. For example, the amount of the insecticide which gives 50% this probability, or 90% or 10%. And this is logit part is equal to 0 if k is equal to 0. So 50%. So so this is the section 4.4.